Now let us talk about the inner product space. What are we going to do? We're going to take a vector space. Let V be a vector space. And let us take two vectors in it. Let U and V be two vectors in this vector space. We're going to define a function, an inner product on vector space V is a function. What does this function do? It takes these two vectors and it assigns a real value to it that associates a real number, which we define as UV to each pair of vectors U and V. It also satisfies the following axioms. First of all, the inner product of U and V is the same as the inner product of V and U. The second axiom, the inner product of U and V plus W is equal to the inner product of U and V plus the inner product of U and W. 3, if C is a scalar, C multiplied by the inner product of U and V is equal to the inner product of CU and V. And finally, the last axiom, the inner product of U and U is always larger than or equal to 0. It is 0 if and only if you have vector 0. Is 0 if and only if U is vector 0. A vector space V along with the inner product function is called the inner product space. And note for you. A vector space V along with the inner product defined on it is called the inner product space. Have I seen inner product in this class? Yes, you saw inner product many times. For example, consider Euclidean space dimension n. Let V be defined for you. The dot product is actually an inner product on Rn. Satisfies all 4 axioms for the inner product. So U dot V is equal to, so if you take U to be U1, U2, UN, and V be the second vector, V1, V2, V3, V4, Vn, U dot V is equal to U1, V1 plus U2, V2 plus UN, Vn. First of all, U dot V is equal to V dot U, it's commutative. Here, U dot V plus W is equal to U dot V plus u dot w, the same. Second axiom is checked. Number 3, c as a scalar multiplied by u dot v can be written as cu dot v. These are the properties of the dot product that we discussed before. And 4, u dot u is always larger than equal to 0. And we know that the dot product between u and itself is 0 if and only if u is 0. So we can say that Rn along with the dot product forms an inner product space. For each definition, remember one example.